These are the 8.1 video notes, and we're going to start looking at confidence intervals. So this is just going to give us the basic idea of what a confidence interval is and what it means. From here, we're going to start looking at getting sample statistics and then extrapolating backwards of figuring out what parameter values are from a sample statistic and trying to start estimating things. Because again, we don't always know the full population value, so it's much easier to get random samples and then extrapolate from there than it is to figure out what's going on in the entire population. And we're going to figure out how we can say this and what these mean. First thing that we need to understand is a point estimator and a point estimate. So a point estimator is a statistic that provides an estimate of a population parameter. The value of the statistics from the sample is called a point estimate. So this is getting really nitpicky with our terms here. If I were to take if I were to do the unemployment thing that the book always talks about, where we get a simple random sample of 60,000 U.S. citizens, and I wanted to figure out unemployment and mean income. If I said, all right, what is the unemployment rate? The fact that I'm taking the unemployment rate from a sample is a point estimator. But then if I said the unemployment rate is 4.9%, well, that's an actual point estimate. So the actual value is the point estimate, the fact that I'm doing it, or kind of the method there is the point estimator. I'm saying that I've got a point estimator because I'm taking the mean salary from 60,000 U.S. citizens. The point estimate would be something like, let's say, $60,000. Mean salary of U.S. citizens is $60,000 from the sample of 60,000 people. That's the point estimate. Going through it was the point estimator. I don't really want you to get too focused on the difference there. The point estimate is so much more important. Next thing that we're going to look at is a confidence interval. So a confidence interval gives an interval of plausible values for a parameter. The confidence interval consists of three separate parts. 1, the point estimate, which we just looked at. 2, a margin of error. And 3, a confidence level. All right, so margin of error. We're going to learn how to calculate the margin of error. In this section, we start looking at it, but we're going to get much more into it in the next chapter. Margin of error is the difference between the point estimate and the true parameter value will be less than the margin of error in a certain percentage of samples. So this kind of builds up. The margin of error with representative distance from the point estimate to the outside edge of a guess. And the confidence interval has the following form. So the point estimate plus or minus the margin of error. So what is this all? And then we'll get into this more. So a confidence level. A confidence level gives the overall success rate of that method for calculating the confidence interval. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter values. And then plausible does not mean the same thing as possible. So as we go through and we find our confidence intervals, as we go through, make our margin of error, and then create confidence levels, a plausible answer is not the same thing as a possible answer. So plausible, we're saying that, like, okay, this is what our data tells us. This means that more than likely the answer is going to be this or fall within this range. If the answer falls outside of that range, that does not mean that we should reject everything that we've done in our data is wrong. Because again, plausible just means more than likely. What's likely, given all the information that we have based off everything we know about statistics, what's likely. Possible means anything, like it could be anything. Now again, there are some possible answers that we are going to start looking at, saying, like, based on our data and the fact that this is here, obviously something's off. Like if we're saying something with 95% confidence lies within a certain range, and then we are like 6 to 7 magnitudes of order off that with the actual value, then we've done something wrong in our calculations. So, but we do want to keep in mind, let's say that I'm looking at unemployed or the mean income in the United States, and I figure out that the mean income in the United States is probably somewhere between $55,000 to $65,000 a year, and I did that at a 95% confidence level. So to interpret that, what I would say is we are 95% confident that the interval from 55,000 to 65,000 captures the mean income of the United States, and that goes along with that last sentence there, so I can read it along again. We are C% confident, 95% confident, that the interval from 55,000 to 65,000 endpoints of your margin of error plus or minus your point estimate captures the mean income of the United States. Now, plausible, again, does not mean the same thing as possible. That means if I go through, we do a census of the United States and we find out that the mean income is 57,000, cool, that was in our range, that makes sense to us. We find out that it's 62,000, cool, it's plausible, makes sense, it's in our range. Now, if we find out that it's 67,000, does that necessarily mean that our calculations were wrong? No, it doesn't necessarily mean that our calculations were wrong. We just came up with a very good list of plausible answers. The census comes out at 67,000. Okay, our range was a little bit off, and why was our range a little bit off? What does this mean? Well, our range was probably off because confidence levels are actually based on the interval, and then I'm actually going to put in parentheses that it's much more the margin of error they're based off of. So when I say that we are 95% confident about something, what that means is if I take a point estimate and add the same margin of error to both sides, in 95% of those trials, I'm going to end up with the true value that I'm looking at. So let's look here at this. So we've got a normal density curve, and let's think that I'm talking about data in the United States again, and I'm talking about margin of error of $5,000. I get a point estimate. I take my statistic, I get a point estimate, I subtract 5,000, I add 5,000. That point estimate might not actually be the mean value, but we can see that in this interval, the mean value is contained. I get another point estimate. I do this a separate time, and then in that separate point estimate, I add 5,000, I subtract 5,000. And in that interval, the mean value is contained. And I keep doing that. I subtract 5,000, I add 5,000. And it's basically saying if I did this over and over and over again, if I didn't just look at one sample, if I looked at many, many samples, and I added 5,000 and subtracted 5,000 from all of those samples, almost all those intervals, 95% of those intervals would end up having the actual value within that interval. 95% of them would. So basically that 95% confidence, I'm not saying that there's a 95% chance that the actual parameter exists within my confidence interval. My actual parameter either does exist in my confidence interval or it doesn't. I've come up with this interval. The parameter is either in there or it's not. And I'm not saying that I'm 95% sure it's in there. What I'm saying is that based off how I do this, when the margin of error that I've created, 95% of the time, when I find a sample statistic and add that margin of error, the parameter is found within that interval. So this is much more based on what my margin of error is than it actually is based on like what that point estimate is. And I'm not talking each point estimate. It's like I'm 95% confident in that if I just kind of like, let's say that I had 100 point estimates with intervals added to it, and I threw it in a bag, and I had that margin of error set to be at that 95% confidence level, there's a 95% chance that that confidence interval that I'm pulling out of that bag does contain the actual value that I'm looking at. It's not about that actual point estimate. So when I say there's a 95% confidence level, that's actually that's saying like based on this, how the sampling works, based on the margin of error I set, 95% of the time with this margin of error, the point estimate I get that interval of the margin of error plus or minus that point estimate will contain the sample mean. It doesn't necessarily mean that it's there or not. It doesn't mean that there's a 95% chance it's there. It's just going about the sampling methods. And I realize that's kind of confusing, and we can talk more about this in class and discuss the concept, but we just want to be careful because it's really easy to fall into the idea that there's a 95% chance that your parameter was within this confidence interval, but that's not what we're saying. And we really want to be sure we're clear with this language. Statisticians can use this language with each other because it's assumed that we know what we're talking about, and we assume that we know how we're talking to each other. But when we're talking to the general public, that changes things a lot. All right, so we've got to check for understanding on this. So how much fat content does brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population. Standard deviation is 2.84 to 7.55. So interpret the confidence interval. So our confidence interval is from 2.84 to 7.55. And I can go ahead and figure some things out here. I'm going to figure out what the midpoint is between these two. The midpoint between these two, 7.55 minus 2.84 divided by 2. So I'm typing this in on my calculator. And I find that this is 2.355. And this 2.355 is my margin of error. I know that that my range here, when you divide my range by 2, that's going to end up giving you my margin of error because that's what I've added to and subtracted from my confidence interval. And then I can also go ahead and I can say 2.84 plus 2.355, and I can see that 5.195 is my point estimate. So when I went through and I found the I found the measured fat content, like the mean of the measured fat content here, I found that the average fat content was 5.195 grams, and then I could say that, all right, we're going through and we're going to add a margin of error of 2.355 to the top, and we're going to add it and we're going to subtract it, and that's going to give us our range. Then we're going to say that, all right, likely the true parameter, likely the true population, the mean, the average grams of fat in these hot dogs is going to be about, is going to be somewhere between 2.84 and 7.55 grams per hot dog. Interpret the confidence level. We are 95% confident that the mean fat content in grams of these hot dogs is between 2.84 and 7.55 grams. And again, that means if I took the sampling method, if I was adding and subtracting 2.355 grams from every single point estimate I got, every single mean value I got, 95% of those intervals would end up containing the true population mean of grams of fat in these hot dogs. And then true or false, the interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. So we're looking at standard deviation here, not mean. So again, we found that the mean standard deviation was 5.195, and we're just trying to figure out. So no, it's not a 95% chance. Either the mean standard deviation is between 2.84 and 7.55, or it's not. It's either it's there or it's not. I'm not going to call it 50-50, but it's like we either have that standard deviation or we don't have that standard deviation. That's all there is to it. But if we go through and we figure out, that we've got that 95% chance, so that means we're running this over and over and over. 95% of our samples, how we run this, would end up containing the actual value. So, all right, to calculate a confidence interval for estimating a population parameter has the form the statistic plus or minus the critical value times the standard deviation of the statistic, where the statistic we use is the point estimator for the parameter. The critical value is a multiplier that makes the integral wide enough to have the state capture rate. The critical value depends on both the confidence level and the sampling distribution of the statistic. So a confidence level decreases as the sample size increases. So your sorry. As the confidence level decreases or the sample size increases, the margin of error gets smaller. So I can make a smaller margin of error if I decrease my confidence level. So let's say that I am let's say that I'm a financial advisor, and somebody's asking based on this like investment that I'm giving them. I can say with 95% confidence, you're going to make you're going to make somewhere between $100,000 and $3 million off this investment. Well, that's cool that they know that they're going to make some money off of it, but that does not help people plan for retirement. They're not going to know how much money that they have to work with. So then they might ask, can you give us a better idea? And then I might say, well, I can say with 20% confidence that you're going to have somewhere between $100,000 and $120,000, or $120,000 off this investment. It gives them a much narrower view of what they could have, but it could be less. It's way less confident. So if we decrease our confidence level, if I want to reduce it and say, yeah, here you go. These are the numbers. I'm not as sure of these numbers, but these numbers exist, and I've reduced my confidence level, and I'm saying that if you do this 100 times, 30 of the times, more than likely you're gonna get these values. But if I do this and I increase my confidence level, I'm going to get a lot more because that margin of error is getting larger and larger. And then if your sample size increases, your margin of error also decreases. So the larger the sample size you have, the smaller your margin of error. All right, we're going to look more at like how to calculate this in section 8.2. This is just introducing the basics. We're going to start getting these ideas and we're going to build on them in 8.2. I realize that there's not much here, but 8.2 will definitely kind of help explain things more. You guys have a homework assignment tonight. If you have any questions or concerns, please reach out and have a great night.